Well, let's do a little work since I found my book. Uh, so today's the 23rd
Yes, sir.
of, of August,
Yep.
which was actually named after a Roman emperor. See, there is no topic. Um, so anyway, this packet that I gave you, I found this on the fine internet, and what really drew me to it is several pages in, there's a section there that talks about the PBR formula I was mentioning the other day, where uh, the part or the percent equals the base times the ratio. So that's pretty helpful. So when I found that, I looked at these um, the other parts of this. There's some really good stuff in here. In fact, I'm going to recommend this to our adult ed people. Because not only does it have example problems, it shows you uh, how to do things. You know, it's just a little reminder.
What, application problems and finance,
Yeah. So look at the page. It's got a little 3 in parentheses down in the bottom right-hand corner. Writing a percent as a decimal. And this is one of the things you're going to have to do. Uh, because a lot of times a problem or even a real world situation will present itself and somebody will say something like, we're going to charge you 5% interest. Well, if you're going to do any calculations with that, well, one of two things is going to happen. Either you're going to look your answer up in a table. In that case, maybe leaving the 5% is just a 5, you're okay. But if you're actually going to do something on a calculator, you have to convert the 5% into a decimal. So let's make sure we all kind of understand that concept. And if you're sitting there saying, yeah, I got this, well, good. So when you're doing percent to decimal, what's the trick?
you take away the percent thing and move your spot to, move your decimal spot to the left.
To the, what did we decide? The left? How many places?
2. One for each circle.
Percentage is percent of 100, isn't it? So one decimal place is just 10. 2 decimal places is 100. So that's why you have that. So number 1 on the worksheet, 8.5%. If you're going to turn that into a decimal, that's 1 decimal place. What do you do now? You have to put another 0 out there, don't you? So there's your second decimal place. Now, I usually write it like that. I like to put the leading 0 there. I think it makes it more readable. Now, this 0 right here has nothing to do with the value, does it? It just makes it more readable. That's just my personal preference. I did start this, didn't I? Yeah. And you remember Tuesday I was talking about units. Always put the units on your answer, and always use units when you're calculating. Percent is kind of an unusual thing. See, I went from I bet I could figure this out mathematically if I just tried hard enough. But on the left we've got 8.5%, and then on the right we've just got a number, don't we? Well, where'd the percent sign go? And if I thought about that long enough, I could probably prove to you where it went. But for all practical purposes, it just goes away.
Oh, the percent sign?
Yeah. So don't get hung up on, wonder what happened to the percent sign. Just imagine that it goes away when you need it to go away.
We changed it into a decimal.
Yeah, I know, but still, it bothers me a little bit that there was a percent sign and then there's not.
That you can't cancel it out that way.
That's right. It bothers me.
Up at the
Um,
top, it tells you that not over 100%, and then it says, the percent symbols cancel each other out when you do it that way.
yeah, that's probably, and as soon as I said this, I hadn't read that part, by the way. I'm pretty sure that's what's going on. Yeah. But it's always, I just been telling students for years, don't worry about the percent sign. Everything else you have to worry about, but not percent. It goes away. But I bet that's what I was thinking when I was trying to come up with, when I said I bet I could prove that. I bet here's what it's probably based on. You remember Tuesday when I was talking about anytime you can express something as being equal to something else, you can use that to change units. So if you look at it like that, and I want to get rid of the percentages, and I just want to come up with a number, 100, and then that's all you got on top, just the one, isn't it? There is no units. Oh, where's my eraser at? So that canceled out I got rid of the percent sign, yes. And of course you're going to get the same, the same answer. But that mathematically proves where we're going with this. Hey, I feel better. That percent thing had been bothering me for years. Been there all along. All right, let's look at one like number 6, because this is the one that typically gives people problems. %. Turn that into a decimal. Well, guess what? The same rule applies that we used up here. Move the decimal place, or I guess decimal point would be a better way of putting that. Let me change that. Move the decimal point 2 places to the left. So, what's that going to be? 9.03. Okay, is everybody okay with that? I think those are the ones that give people the most problems. So 900% increase is like you multiply it by 9. 900% is a lot. Okay? I'll tell you something else that drives me crazy. When somebody says, well, we experienced how would they put it, the ones that really drive me crazy? 150% decrease. What's that mean? Really? What's that? There's a better way of wording that that's not confusing. Anyway, was everybody okay with the concept there? Let's look at the next page. Writing a percent as a fraction. I could have left that page out. I'm not terribly worried about that. I think it's important to go the other way. Do we have a section there that says converting from a fraction to a percent? Yeah, it's on a couple pages further on. So, page 4, writing a percent as a fraction. Not worried about that.
You want us to do the writing in decimal as a percent?
Yeah. So this is on page 5. This is actually going the opposite way, isn't it?
Mm-hmm.
So, let me write that down. So this is decimal 2%. I was trying to think of good applications of this. So usually in conversation, we would refer to something as percent. If you were doing some sort of calculation and you come up with 0.05, you wouldn't look at your best friend and say, it's 0.05. You wouldn't say that. You'd say it's 5%. Okay? So we tend to talk in percents, but we have to calculate in decimal. So, what's the rule here? Move the decimal point, what? To the right 2 places. There you go. So let's look at, how about number 3? That's always a So let's see. 1, 2. So that's 5. And there that percent sign popped back up again, didn't it? It goes, it comes. But I know where it goes now. I feel better. How about number 8? Or how about number 5? 1.75. Yeah, it's going to be 175%, isn't it?
That's how much I get.
So when you look at this, any decimal that's greater than 1, you're going to have more than 100. Okay? If that had been 2.75, it would have been 275%. Okay. Y'all okay with this?
All right, now number 8, let's try that one.
All right, number 8. Give me a little more page here.
That's the part.
006. Well, just follow our rule here. 1 decimal place, 2 decimal places. So it's going to be 0.6%.
That's what I thought, but I wasn't sure.
Mm-hmm. Yep.
And number 9 would be 550%.
Yep. That's a lot.
I think they just threw that out there.
Well, they try to give you an assortment here and try to make sure that you see all the different possibilities. I usually throw in odds and ends as I happen to think about it, and these things are getting more and more random. If you watch the news, or if you watch any sort of financial news, which I really don't watch a whole lot of financial news, but every once in a while you'll hear on the news they'll talk about the growth in GDP. Y'all know what GDP is? Gross domestic product. It's the sum of the goods and services for all of us every year. GDP, gross domestic product. Doesn't have to be for a year, just some time period. A GDP growth of 3% is actually pretty good. Now, last quarter rather, the United States was actually at 4%. And of course, whatever administration is in charge or thinks they're in charge will take credit for a 4% growth. That sounds good. I'm kind of curious what it's going to be this quarter, because there are seasonal things that happen that can throw everything off. So 3 or 4% growth as far as the country's output, it's actually pretty good. And it doesn't seem much if you just look at 3%. I mean, that couldn't be anything important. Yeah, actually it is. Okay. Now, I'll throw another little wrinkle out there and let you think about this, because I think this is fascinating. We have something called the Federal Reserve System in the the United States. Y'all heard of the Fed? All right, shake your head. You've heard of the Fed. They control the main interest rates. They control monetary policy. Okay? The Fed they have a target for inflation. Does everybody know what inflation is?
That's how much everything goes up.
Yeah, the price you pay for things to go up over a period of time. The Fed shoots for an inflation rate of 2%, which means if you buy something this year for $1, next year it'll cost you $1.02. Okay? Now the reason they shoot for 2% is they want to make sure that there is a positive inflation rate. Now think about that. The Fed is saying that inflation is good. Now, here's the reason that the Fed thinks inflation is good. The opposite of inflation is deflation. That means prices go down. Now, here you are, if you're sitting there and prices are going down, we're at a period of deflation, and you want to buy a car. Are you going to buy the car now, or are you going to wait for it to go down? You're going to wait for it to go down. D'Angelo's like, he's figured this out. So if you have deflation, everybody stops spending money because they're expecting prices to go down. Well, what happens when people stop spending money? Prices go down even more. So then you get into this death spiral thing, okay? So deflation is not a good thing from an economic standpoint. So therefore the Federal Bank shoots for slightly positive inflation rate. Then if they don't quite get there, they don't have to worry about it going negative. So 2% doesn't sound like much, but it still plays into people's calculations. Okie dokie? Y'all didn't know this was going to be an economics class, did you? Let's see here. Everybody okay with that page? Y'all can work on these
Let's do 6.
over the weekend.
Can we do number 6?
We did number 6, didn't we?
Oh, yeah. Yeah.
Oh, we did number 8. What is number 6?
309%.
That's right, 309%.
I'm ahead.
And that's a lot, by the way. Let's look at page 6. Writing a fraction as a percent. Now, I do think this is important. Now, there are some things that you can just kind of glance at and say, "Boy, I know what that is." For example, just glance at number 1. You know what that is? Let's look at it. What is that as a percent?
70%.
It's 80%. You can figure that because 50, the denominator of 50, figures well, you know. Put that in, divide that into 100 to get 2 times 35, 70%. Some of these are maybe not as, like number 8. That's not as handy, is it?
No.
So what I'd recommend on these is, if you glance at something and it's real obvious, good. But if it's not, let's do, how about number 6? 1 and what? 9 over 40. Let's do that on a calculator. And I got to turn on I need to open up a calculator. So how would you do number 6 there? Here's what I do. I do it in 2 steps. Do the fraction first. 9 divided by 40 is 0.23. Now, here's a little gotcha. On this calculator, I have told it I wanted 2 decimal places, but that's not the right answer. It's like 0.225. Now here's what you do on this particular calculator. If you go here to mode, click on mode, and if you look at the second line there, it says float and 0, 1, 2, 3, 4, 6. So I've got it on 2. I have forced this into 2 decimal places. And for if I'm figuring money, that's okay. In this case, I'm not figuring money, am I? So I'm going to put it back on float, press enter, and just bail out of here. So watch this. Another thing that's really interesting on these calculators, I don't want to have to type that in again, so I do second, and down here at the bottom, the second functions are up above the buttons. So this is second entry. Look, I got the what I previously entered back, and if I did second entry again, I'd get the thing before that, and second entry again, the thing before that. So you can save yourself a lot of typing. So now press enter, and there's my 225. Okay, so keep in mind every once in a while you might have to change the number of decimal places your calculator is showing you.
So do we just put the 1 in front of the 2?
Well, I just do this. Now watch. Now I'm thinking, well, what about my 1? Plus, see what it did? It said answer, and that's the previous answer. So I didn't have to put in the 225. It just grabbed it for me. 1, enter. So this is 1.225. And a little sales pitch for this type of calculator. Go on eBay. They're selling for about $25. I think they're well worth it too.
So did we put the 1.225 on top 40? Or was that
No. Now, well, wait a minute. We're not done yet, are we? This is just a number. This is a decimal. So this is a mixed, what we call a mixed number, fractions and whole numbers. We turned it into what? A decimal. But the instruction said do what? Go to a percent. So now what are we going to do? 2 decimal places to the right. Now let me show you something else here. On this particular calculator, let's see if I can find it. Look over here on the left. Little button here says math. Watch this. Press math, and let's see here. This one will let me do fractions and decimals. I bet if I look around here in a minute, I can find the percentages. I'd have to think about it. That's something I just don't ordinarily do in my head. But this one will do fractions, decimals to fractions, and fractions to decimals. I'll think about it. I bet there's a percent conversion on here as well. By the way, this little calculator here is like, I don't know, 100 times more powerful than with calculators and computers we went to the moon with. Yeah, late 70s, they would have killed for this. Or late 60s, they would have killed for this. I'll look and see if there's a direct function on there. I'm sure with financial calculators there is. Alright, is everybody okay with this type of problem? Deal with the fraction first, then add the whole number to it. That gives you a decimal, and then convert that to the decimal, if that's what you need to do. The next page, 7. I wouldn't worry about that third column there. Well, yeah, you could. Here's what I would do. On page 7, look at the top line. It says, well, there you got a fraction. But we can do that. We could convert that fraction to a decimal and then to a percentage, couldn't we? So, line one, you can do everything. Line two, I think the decimal to percent conversion is important. I am not worried about going from 5.3 to a fraction. So I wouldn't worry about converting anything to a fraction, but if you've got a fraction given to you, you can do the other two. See what I mean? So, like number 2, don't worry about the fraction. 4, don't worry about the fraction. 6, 7, and 8, and 10, don't worry about the fraction part. Okay? All right, is everybody okay so far? Nobody's head's exploded? Oh, I need a... On some of them we will. You don't have to worry about the third column on 2, 4, 6, 7, 8, and 10. Okay? There you go. That'll work too. Draw an X.
X marks the spot.
2, 7, 8, 10.
2, 4, 7, 6, 7, 8, and 10.
Yeah, 2, 4, 6, 7, 8, 10. Page was that? 7. Don't worry about converting to fractions. And the reason I'm not worried about that is very seldom I think you'd have to do that in the real world. Now, a lot of times, for example, if you did some calculations and you come up with 0.5, and mentally you could say to yourself, ooh, 50%. That's about half, If it's something you ordinarily can just do in your head, okay. But converting something into 4/7 or, not that big a deal. I just try to do practical stuff. All right, let's see where we're at. Next page, finding a percent of a number. I don't know why they said a percent. Looks like it ought to be the percent. Well, I can see where they're going with this. So let's, you want to read how they say do it, or you just want to jump in and we'll do it ourselves? Now, there's several different problems here. Excuse me, several different types of problems. So let's look at this. Number 1, and let's talk our way through this. So this is finding a percent I've also noticed that as time goes by, my writing gets worse and worse. So, and I'm also having to lean halfway to the back of the room to get to the writing surface. Number 1. Find 150% of 82. Okay. Well, 100% of 82 is what? 82, isn't it? So, it's not going to be possible to directly multiply 150 times 82, is it? We need to do something to the 150% first.
You're going to take the percent
right. We need to convert 150 to a decimal. So 150% is what?
1.50.
1.50 in decimal. Now we can go 1.5 times 82 equals 123. So that's our answer. So on this particular type of problem, we have to convert the percent into a decimal before we can multiply by this other number. And the 82, you could say, well, that's a decimal as well, because you could say 82 could be expressed as 82.0, so they're both decimals. Okay, so that's one type of problem we have here. It looks like number 6 is a similar problem, but number 2, yeah, number 2 is the same type of problem. 7, I thought these were different types of problems, but I guess they are all the same, aren't they? Okay. Which other one here you want to work? Pick out one that you think is number 8 or number 3. What do you want? Which one do you want? Number 3. Find 5% of 200. Let me just throw something out there. I was talking Tuesday about either estimating or always trying to look at an answer and see how reasonable it seems. You know, the first thing I would do when I see this problem, I'd say, 1% of 200 is what? 2. So 0.05% is going to be a lot less than 2. So if I work this out and get an answer of 34, it's like, uh-oh, somebody goofed like me. All right? So I usually have an idea right off the bat of what kind of number I'm looking at. So just like before, let's do this. 0.05%. We go which way with the decimal place? To the right?
Or to the left, I mean.
Or to the left?
0.0005.
0.00. Oops. Wasn't a very good 0, was it? 0.5. And of course the reason here is you need to do this and this. So that's where those other 2 zeros come from. All right, is everybody okay with that? So now we can go 0.0005 times 200, and the calculator says clear 0.05 times 200. Now 0.1 is definitely less than 2.
Yep.
So I feel, pretty good about that. Okay? If I'd have somehow not moved my decimal enough and come up with 10, that would have been a red flag because I was expecting something less than 2. Okay? It's always a good idea to have an idea of what you're expecting. All right, y'all okay with that?
Yeah, well, number 6 is a harder one, but number 18 is harder.
Which one you want?
8.
Number 8. Okay. %400 of 52.7 So 400% is, what is a decimal?
4.00.
4.00? So 4.00 times 52.7 is 200 point something.
Would be, 210.8.
4 times 52.7? Boom. 210.8? Okay? I think we should be okay with the rest of those. The next page, which would be page, I don't know, what page is that? We've lost the, I guess it's like page 9 because 10's the next page. Yeah, page 9. Solving percent application problems. So this is the part I really thought was interesting. The rest of the stuff is good practice, good drills. So let's read the top part here because this particular part and in the book it words this a little differently. Here's what they have in the book, and this is introduced in, what chapter was it? It's the one with the decimals and their applications, I think is the name of the chapter, which I think it's the one I told you to get a chance to glance at it. Yeah, it's number 6. So after all this, we actually are pointed back toward the book. So in chapter 6, the concept you see here on this handout is actually introduced, and it's done a little bit differently, and I think it's probably easier to remember like this. This is what the book says, and you can translate this into exactly what this handout tells you. So the book talks about a portion being the base times some rate. Now the reason I like this is PBR. I think I told y'all the other day, I don't drink, but I can remember PBR. Why? When I say PBR, what do y'all think of?
Radio.
Pabst Blue Ribbon. Never had one in my life.
Radio.
Hmm?
Radio. PBR radio.
They're probably sponsored by Pabst, aren't they? I think they'd have to be. About have to be. So anyway, I think it's just easy to remember PBR. Okay? And this is what it means. The portion equals the base times the rate. Now you can rearrange this as you need to. And I'll give you an example of this. If I had $100,000, that's a laugh, and I told you that I'd give you 10% of it, what would you do? You jump up, after you got through jumping up and down, of course, or asking me, what do I have to do for the 10%? The base in that case would be, whoops, why did I write an 8 down there? Sometimes my brain just goes off on some tangent. I think what it was, I was thinking I needed to put the dollar sign out in front. That's my story, and I'm sticking to it. 10% is
$10,000.
0.01. So you multiply that out, and your portion, if I decided to give you 10%, Maybe you're my agent or something. I don't know. Your portion would be $10,000. Okay? So this PBR is handy. It pops up quite a bit throughout the book. So just remember PBR. Now, depending on what you're doing, sometimes P equals BR can become PR. Whoops, I got to do this. What did I do? I just rearranged the terms here. Actually, I divided each side by R, and on the left it canceled out, leaving just the B. So that works. And I could also sometimes need to say something like that. Same concept, only in this case I divided each side by B. Okay, so this is solving for the base, this is solving for the rate. Okay, so you can rearrange this as needed. Would I remember these last two equations? No. Remember the first one, you can rearrange it when you need it. Okay? So this is actually very handy. So let's look at a problem or two here. Which one do you want to do? How about number 2? So number 2 here says 1.3% of, how many computers were they? 1,500 computers were defective. So what we're looking for here is how many computers is that? So what we're going to do here? Well, first thing we're going to have to do, regardless of whatever else happens, is we've got to change that 1.3% to what? Decimal. So 1.3% is, what is it? Okay, is everybody with us? Because we need 1 decimal place, 2 decimal places. Okay, is everybody with me so far, or with us so far? Okay, now let's look at our numbers. This, the 1.3%, sounds like a rate to me. That's the defect rate, isn't it? Think about it, defect rate. Now, what do you think the 1,500 is? That's the base. Now, the defective part is the portion. So remember, the portion equals the base times the rate. Now the good news is here, we want to know the portion. The formula is already in the correct form, isn't it? We don't have to do any manipulation. So P equals 1,500 times 0.13, and the calculator says nothing, you have to read it. 1,500 times 0.13. What'd y'all get?
19.5. So basically 20 computers. You want us to round back to the-
I'd round that one up.
So it'll be 20.
Yeah. And these little squiggly lines here means about. I'm not very good at doing squiggly lines. Okay. So look through these rest of these here. Which one do you want to work? Let's work one more and then we'll declare victory. Number 8. Okay. Make sure we got enough room here. Yeah, I think we do. Number 8 talks about brass, ordinary brass. And that's 61.6% copper, 2.9% lead. I wonder if that's really, I wonder if brass still has lead in it. I wonder how stable the lead is. Lead's not good. Lead can, make you even stupider than you already were.
Yeah, but I'd say
We
it's
don't
pretty-
want lead, do we?
I'd say it's pretty stable, I think, pretty good coming in.
I don't know. Well, see, some of these things don't really react chemically. There's something called amalgamation. You just put some stuff together, and it's not really chemically bound. I don't know. I don't remember what the deal for brass is. Anyway, it's got 33 or 35.3% zinc in it. So we want to know how many pounds of each metal would be in 160 pounds of brass. So what we're going to do first.
Change all into decimals.
Yeah, we need everything into a decimal, don't we? Point, let's see, 61.6 is a decimal is, okay. And the 2.9% is 0.29. And the 35.3 is 0.353, isn't it? Okay? Are we okay? Got all the numbers right?
You were also missing 10.
10.
Where?
It's 0.2% is 10.
10. T-I-N.
Oh, did I miss one?
Yeah.
Yeah, I did. We can't put that in there. My page is not wide enough.
I thought you were just skipping it.
I don't have enough room. We can't put 10 in this. I'll put it down here, so that's going to be what? 002? Okay. Yeah, you got to put the 10 in or it's not brass. All right, have I got them all now?
You take each one of them and pound them all in 60 then.
Right. So let's see, for this one is copper. You're going to have 160 pounds times 0.616. I'm going to write them all down, then we'll come back and do them. Lead, 160 pounds times 0.029. The 10 is 160 pounds times 0.002, and finally zinc is 160 pounds times 0.353, wasn't it? Okay. Calculator. 0.160 times 0.616. For the amount of copper, I got 98.56 pounds. Okay. Now, if you do second entry here, you get the 160, and then you just go right in here and change this. 0.029, 4.64. Second entry, 002. 10 is 0.32 pounds, what y'all got? And finally, zinc, 353. $56.48. Okay. Everybody okay with that? Shoot, we've done run past the end of the class. So work on everything we've done up to here, and we'll worry about the rest of it later. Again, if you get a chance to look at chapter 6, I might get inspired and might find a homework problem or two in there, but if I do, you'll have plenty of time to do it. And we'll go over the rest of this next week. I think this is a pretty good packet. I like this. There's good stuff in here. Good review. Okay? Y'all have a good weekend.
So do the whole packet?
No, just do up to what we've done so far, the ones we've skipped over. I usually tell my classes, of course, I don't think it's going to be a big thing with you guys, but whenever I got a class that's got a lot of boys in it, I say, now look, if you're doing something over the weekend and you think you need to turn around and yell to your friends, hey, watch this, stop whatever you're doing. Because it's probably not going to turn out good. Okay? Those are the magic words. Hey, watch this. No.
I just know
No.
the ones that